Welcome back to my devlog and tutorial about the making of Chronicles of the Fae Walkers. When I started working on this version, I quickly came to the realization that handcrafting the entire world would take a long time. Certainly many areas would be created by hand, but for the in-between traveling areas, would it be possible to let the system create them? Would it look natural? Only one way to find out. The process shown in this video is known as procedural generation, which is basically letting the system do the creating or world generating for you. For this video, I'm pulling the code I already wrote for my game and making it a standalone project for clarity. It's the exact same code as used in my game. I started by creating a new project and dragged in my tile map image asset. It's a 2D project and I added a tile map layer node. In the node, you specify the dimensions of each tile. Then, in the TileSet tab at the bottom, you can drag in your tile graphic. Make sure the tile size matches the size of the tiles in your tile set. In this case, it's a 128 pixel by 128 pixel size tile. Click on the Select tab and look for Physics. If it isn't there, go to the Node Inspector for the tile map layer and add a physics layer. The physics option will now be shown. If all tiles are walkable, you don't need to do this, but if you want to prevent players from walking on water or off a cliff type of tile, then you need to mask out the areas they can't walk on. The tile map I'm using is one I purchased from Daniel Thomas. He has a series of tile sets and characters that really fit the look I have been envisioning. If you're using this as a tutorial, just adopt tile size and concepts to your chosen tile set. The concept and example here aren't specific to any particular tile set. Most will work just fine. With the tile set configured, I can drag tiles from the tile set onto the tile map, one by one. For the 18 tile example here, it took about 45 seconds to drag in place. Now imagine a 10 by 10 playing field with 100 tiles, or a 100 by 100 field with 10,000 tiles, or a 200 by 200 field with 40,000 tiles. That would be about 24 hours to place every tile by hand. I also don't want just one playing field, but rather multiple, perhaps a half dozen. That's 20 days at 8 hours each day of simply tile placing. No thank you. There has to be a better way for the system to generate a playing field. It won't be perfect, but instead of placing tens of thousands of tiles, I can just place tiles into small areas where I want a specific scene set up. However, I also don't want every time you play to be a different playing field. In some games this is good, but when I'm creating specific areas within the map, I want the rest of the map not to change. So I'll need some way to save what is created for later use. I'm not going to go over every line of code, but rather just an overview of functions and routines within the code, and the concept and thought process behind these. I don't claim this is the only way or even the best way, but it's how I figured it out and made it work. First, I need to define an array with the tiles I plan to use. There are 26 different tiles. I'll fix the mistake in the code later on. And for each tile, I look at the top, bottom, and left and right sides. Based on this particular tile set, I define each side with 2 letters. If both halves of the side are grass, then it gets coded as GG. If half is grass and half is sand, then its code is GS or SG. By following a consistent approach of always analyzing the side left to right or top to bottom, I can code each side. I then translate, in this case, the 4 possibilities of grass grass, grass sand, sand grass, and sand sand into numerical values 1 through 4. Each tile is coded in order of top, right, bottom, and left. The array holds the 4 values and 2 more, which are the coordinates of the tile. Top left tile is 0, 0. The next one to the right is 1, 0. The one below the corner is 0, 1, and so on. When completed, the array contains a definition for each tile. Now when a tile is placed on the playing field and I want to place another one, I examine the options in the array. Using the right side as an example, if it is grass sand, then it can only match that to a tile that has grass sand on its left. If the top of my tile is grass grass, then above it I can only place a tile that has grass grass on its bottom. I start by randomly placing the first tile on the playing field and then loop through every position, examining the tile spaces around it for possible candidates. Once I have a candidate list, I then randomly select one of the candidates and place it, and then repeat for each position. There is a possible condition where you simply can't find a tile with the necessary side combinations to fit. In the example here, using just grass and sand, that would rarely happen. But in my full game where I also have dark grass, water, dirt, and cliffs, this condition came up often enough. The coding was actually pretty simple. If I can't find any candidates, then I delete all the squares around the problem tile and simply let the next pass through the playing field try to fill it all in again. Now I'm not actually putting squares in the playing field, but rather in a two-dimensional array. Once that array is filled with all the valid tile values, I then finally output the array to the screen. In the case of small fields, say 10 by 10, this is essentially an instantaneous process. Large fields like 100 by 100 take several seconds. A 200 by 200 took upwards of 5 minutes in my game. Altogether, the code took me about 15 hours to create and test. If I wanted to create 6 different playing fields by hand, with 3 variations of each, this could be 2 months of 8-hour days, 7 days a week to create by hand. Instead, 2 days of work creating the code, and now I can generate a new playing field in a few minutes. I also have the code available for use in future projects. I consider this a major win. To create the save option, I added a key input and function. It works by simply saving the current node to a resource file in your project when you press S. Once you quit out of the program, the resource can be added as a node to the game. However, be sure to remove the script from the added node, or better yet the resource, as Godot will then try to generate 2 maps if you run it again. Since the save name is always the same, be sure to rename the resource to avoid overwriting it with your next save. A simple but effective solution. Run it multiple times to generate and save multiple variations. While this generation works just fine, it could be expanded by incorporating a weighting system. For example, grass or water might be more heavily weighted, resulting in mostly plains world or a water world with islands. Finally, in Chronicles of the Fae Walkers, here is the result using more tile types. In my current project, the river system and the large lake were created by hand after generation, with most of the rest of the map being auto-generated. There is a day-night cycle with lights coming on at dusk and going off at dawn. There's also a random rain event where it gets darker, which makes it really dark at night. I haven't decided if I want to keep this as more realistic or if I want to tweak the values to make the gameplay easier. A simple inventory and dialogue system is working, although also showing some glitches that need to be worked through. At this point, many of the game mechanics are falling into place. Once those are all completed, the next steps will be content creation and testing. I hope this was helpful, and if you have any questions or comments, please leave them below. Don't forget to like and subscribe.